Thank you. Sorry for being late to this morning. It's been a little bit trouble for me. I'm here to describe my PhD thesis, and part of my thesis that is optimized ISAC waveform design in 6G networks. So I'm going through what is a 6G network in my case, and what is an ISAC system, and what is the purpose of optimizing a waveform for this kind of system. So first of all, the vision. So we have this kind of environment in which we have a smart environment. So we have entities that could be users, cars, and everything that communicate between each other. And what is the vision for 6G? We should have environmental awareness and AI, so intelligence. And what are the KPIs? So we have the current 5G system that fulfills only some requirements. But for 6G, we are trying to have a localization precision that is going to be enhanced. So we want to perform sensing, so environmental perception of what is surrounding the vehicles or the entity that it has to communicate. So what is an integrated sensing and communication system? We have a system that wants to do both communication and sensing at the same time. So it wants to communicate towards an entity, and in this case we have a base station that wants to communicate towards the UE, that could be the user or the car, and has to perceive what is in the surroundings, so maybe the trees. And we want to do by exploiting the same resources, so the same hardware and also the same resources in time and frequency. So communication is done by exploiting time and frequency resources, and we want to use the same resources for both doing communication and sensing. And this is called co-design. And what are the benefits for doing this? We can have improved beam management. Of course, we are using high frequencies for performing sensing and communication because we need a lot of bandwidth and we need a very high data rate. And so we are improving the beam. And also we have to deal with blockage. So in this kind of scenario, we have the communication that is directive, and the attenuation is very high in case of an obstacle that is within this link. And of course, data collection of what is the surrounding. So actually, it's a complex task because we know that integrated sensing and communication is a game of trade-off. It is a game of trade-off because we have different KPIs for communication and sensing. So on one hand, we have for communication the rate or the spectral efficiency, while on the other hand, for sensing, we can have maybe the camera bound for localization or imaging or resolution and so on. So we have to deal with this system in which we have communication and sensing that are in the opposite direction. So if we improve too much communication, we lose sensing and the opposite. So the first proposal that we did for waveform design is that is superimposing two different waveforms. So we have the classical waveform for communication, that is OFDM, that is superimposed with the one of sensing. And for sensing, we define a waveform that is like flat in time and frequency domain, that is the domain we use for communication. And in this way, going through Doppler and delay, we have a very high spike. And we optimize this kind of waveform in order to reduce the interference between the two systems. And in this way, we are able to not change the standard for communication and achieve the same performance for communication, while at the same time obtain a very high accuracy in localizing the targets. And another point is that usually base stations are not designed for working at full resource occupancy in time and frequency. So usually we have some holes within the spectrum, and we have to deal with dispersity. So this is another waveform that has been defined in order to deal with a sparse system in time and frequency. And of course, when have unused resources in time and frequency, this leads to another trade-off. So we do not have only a trade-off between communication and sensing, but we have a trade-off also within the sensing domain, between the ambiguity function, that is the height of the side lobes, that can create ghost targets or misdetection, and the camera bounds too. So this is a solution for dealing with this kind of system that is a kind of interpolation of the sensing channel by exploiting the fact that the sensing channel is sparse in the delay and Doppler domain. And actually what is obtained here is that the side lobes that are like very bad for sensing because they are increasing the probability of misdetection are going to be reduced. And so what we see from a sensing point of view is like a very high spike that localize our target. So what is the conclusion of this work? Is actually ISAC is a new topic that is a game of trade-off. It's very complex, so it has to be discussed fully, and we have this trade-off between communication and sensing. And ISAC, of course, can be handled in multiple applications. For example, environmental sensing. Now they are dealing also with biomedics and so on. So while doing communication, also performing some kind of sensing. And waveform design is a very, very complex task because it has to consider both communication and sensing KPI that are on the opposite direction. So thank you for your attention.